This is example 3.4 from Discovering Design with Chemistry by Berean Builders. The question asks, the shortest wavelength of visible light is about 380 nanometers. What is the energy of that light? So first, let's look at this problem and see what we have. We have the shortest wavelength, blah, blah, blah. This is a wavelength, and they want to know what is the energy. So given the equations that we've looked at so far in this chapter, we have this equation, which deals with frequency, wavelength, and the speed of light. Well, that's helpful because we have a wavelength here. That could be useful. And then we have this one that has energy, Planck's constant, and frequency. That could be useful because the question asks about energy. So to get from where we are to where we need to be, we have wavelength and we need to get to energy. So we're going to start with this one because it has part of what we need. It has a wavelength in it. The wavelength, when we put it into this equation along with the speed of light, the C that we know, the C and the H are highlighted yellow because those are constants. They're always the same number, and those numbers will be given to you on the test or any other assignments in this course, and so you don't have to memorize the numbers. But if we start with that equation, the C and the wavelength, those are both taken care of for us, and it will give us the frequency. And then we can use that frequency in the next equation that we just recently learned so that we can find the energy. E is for energy. So let's get started. F equals C over wavelength. So let's put in what we know. 3.00 times 10 to the 8th meters per second. And, oh, drat. As it turns out, we can't just jump straight to that equation because we have nanometers. So if you started this and then realized that you need a meter down here, good job. If you didn't, take your paper to the side and convert it. So if you don't remember, and I don't have it written this time, 1 nanometer is 10 to the negative 9th meters. That is one of the things that you should have memorized. In my edition of the book, it's on page 76. If you don't have, I would recommend making a little note card that has all the things that you need on there so that you can easily refer to them while you're practicing problems and working on memorizing them. All right, now it's been converted. If you didn't follow what I did just now, just pull out your calculator and type in 380 times 10 exp, or whatever your scientific notation button is, -9, hit enter, and it should give you the correct answer. All right, so you know what I just realized? This 0 is not significant, so I actually can only have 2 significant digits, so I'm going to erase this other 0. All right, so now let me put that in. So 3.8 times 10 to the negative 7. All right, my meters will cancel, and I'll be left with the right units for frequency. I don't know if my calculator on Windows is going to like this, but I want you to be able to see what I'm doing. So I'm going to try it anyways. All right, 3.8 exponent. I'm going to try to type in my -7 in parentheses, and then close that parentheses. And did it like it? No, it did not like it. All right, I'll try it one more time. If it does not work, I'll have to do it on my calculator. I don't know why I can't get this thing to accept my negative exponents. 3.8 times. Let's just try to type in -7, see if it likes it. Oh, no, it did not like that. It just weirdly subtracted. Okay, sorry guys. Actually, I can probably type it on this one. Sometimes this one likes it better. All right, so 3.00, 10 to the 8th. We're going to divide that by 3.8 exponent -7. Aha! All right, if you're using a regular scientific calculator, this is what you should get. Because 3.00 has 3 significant digits and the other one only has 2, 3.8, we can only have 2 significant digits. So we can only keep the first 2 numbers here. So we're going to round the 8 up. So that'll be 7.9 times 10 to the 14. So let's go back here. So our answer here for our frequency is 7.9 times 10 to the 14th. And we can put that in hertz, or we can put it in, we can leave the unit as 1/second. You can also write hertz. Either one is fine. Now that we have the frequency, we can move forward in our problem and use the second equation so that we can find the energy. All right, so let's start. Let me get a new color here so I can work with a little more clarity. So E equals H times F. So H is a constant, so we can just type that in just as it is. You don't have to memorize that. And its unit is joules times seconds. And then we're going to multiply that number times the frequency that we just found, 7.9 times 10 to the 14th. And this is why I put my units as per second, because it's easy to see that these cancel out. I do not know if my calculator on my computer works, so I'm going to again use the one in my that I found online that I've used. So I'm going to type in 6.63, and then I'm going to use my little exponent button, and -34, and then I'm going to multiply that all times 7.9, and that's times 10 to the 14th. All right, and the answer I get, again, the 7.9 has only 2 significant digits, so I'm going to only keep 2 significant digits. The 2 has a 3 after it, which means it will not round up. It will round down just to plain 5.2 times 10 to the -19. So E, where did my pen go? E equals 5.2 times 10 to the -19. And notice the only unit I have left is this J, so that's in joules. And that's how the energy unit, joules is a unit of energy. And so that's my answer for that one. Notice we had to take 2 steps to get to this answer because they gave us something that the energy equation does not have. And so we had to use our old equation for frequency to get the frequency and then use that in our energy equation to get the final energy.